Hello everyone, this is Ma'am Berlin and we will be tackling about molarity. In this part of the lecture, we will be giving word problems related to molarity compared to the previous lecture in which we just gave the or identified the given values. But here we will relate this on word problems. Again, molarity is denoted by capital M and it is defined as the number of moles of solute per liter of solution. Algebraically speaking, it is expressed as capital M is equivalent to N over V, wherein the capital M is the molarity, the N is the moles of the solute, and then the capital V is the volume in liters of solution. All right. For the first sample problem, we have here how many grams of potassium dichromate are required to prepare a 127 milliliters solution whose concentration is 2.13 molarity. So that is the problem number one. First, we have to identify the given values. We have here the given values of volume expressed in milliliter, which is 127 from the problem. And then the given molarity is 2.13 m, or molarity here. All right. So we are being asked again to find the grams. But then we can't find the grams here. We have to find first the mole. And then we have to convert the mole into gram, right? So we have here the original formula, which is m equals n over v. So manipulate that using the triangular expression. You will have to find the moles of solute. That is, you have to multiply the molarity times the volume or liters of solution. Therefore, to find the moles of potassium dichromate, all you need to do here, we have the value of your molarity. Again, that is given, that is 2.13 m. And if you will expand the unit of m or expand the unit of molarity, that is moles per liter of solution, right? Moles per liter of solution. Pag i-expand nyo yung 2.13 m, that is moles per liter of solution. So, therefore, that is the value of your molarity, which is 2.13, and then expand the M unit, capital M unit, that is moles per liter of solution. Moles of the potassium dichromate, and then in 1 liter of solution, that is molarity. Multiplied to the liters of solution or volume. The volume originally is 127 milliliters. Convert that into liter, that is 0.127 liters per solution, converting to liter from milliliter. And then the next thing that you need to do is cancel units. Cancel the units, like you have to cancel the liters of solution, You will be left out with the mole unit. And then the next thing that you need to do is you have 2.13 over 1 multiplied to 0.127. You will have 0.271 mole of potassium dichromate. The next thing that you need to do is identify the molar mass of potassium dichromate. The potassium dichromate has a molar mass of 294.2 grams. So therefore, we will write to find the grams. Since we are looking for the grams, we already have the moles. We can convert into grams na. So converting the moles to grams, so we can find the potassium dichromate in terms of grams. You have to 0.271 mole potassium dichromate, write the expression wherein you can cancel the mole unit and you can obtain the gram unit. So in 1 mole of potassium dichromate there is a 294.2 grams of potassium dichromate. You can cancel down a mole, cancel the mole. You will be left out with 294.2 grams. And then multiply that, you will have multiply this 0.271 to 294.2, you will have 79.73 grams of potassium dichromate. Therefore, in order for you to prepare a 127 milliliter solution that has a concentration of 2.13 m, you have to weigh 79.73 grams of potassium dichromate. All right, that's how you do that in a laboratory. Next, sample problem number 2, what is the molarity of 45.0 milliliter ethanol solution containing 3.72 grams of ethanol? So for the problem number 2, we have the following given. Again, we are looking for the mole. We have the value of the grams, which is 3.72 grams of ethanol. We have to convert grams into moles. The value of your volume is 45.0 milliliters. We have to convert that into liters because molarity is expressed in liters. All right. To convert this one, all you need to do is divide it into 1,000. All right. So you will have 0.45.0 will become 0.045 liters. Okay, from milliliter. And then converting grams into moles, you just have to write the given gram, which is 3.72 grams of ethanol, and then write the expression in which cancel the gram unit and obtain the mole unit, such that in 1 mole of ethanol, there is 46.07 grams of ethanol, right? If you get the molar mass of this one, that is 46.07. And then you can cancel now the grams, cancel the grams. You will be left out with the mole unit. And then 3.72 times 1 divided by 46.07, that is 0.08 mole of ethanol. You now have the mole. Okay, so from here, you can find now the molarity. Okay, because molarity is mole per liter. So the value of your molarity here, the value of your mole is 0.08 mole of ethanol, this one. And then the value of your volume is 0.045 liters. All you need to do is divide that 0.08 divided by 0.045, that is 1.78 molarity. All right. So therefore, the molarity of the 45.0 ml ethanol solution containing 3.72 grams of ethanol is 1.78 molarity. When we talk about molarity, how strong is the solution how strong is the mole per solution? All right. That's what I mean by that. Next, we have here the third problem, sample problem. We have here in a biochemical assay, a chemist needs to add 7.25 grams of glucose to a reaction mixture. You have to calculate the volume in milliliter of a 4.21 molarity glucose solution. Okay, the amount that you should use for the addition. Okay, so the given values for this one, we have the following: the molarity value, which is 4.21 m on the given problem. We also have the value of the grams, which is 7.25 grams of glucose solution from this one. You are being asked to find the volume in milliliters that she needs to add so that she can have the molarity of 4.21. Okay. Now, the first thing that we need to do is convert grams into moles. We have to convert this one, grams into moles. So converting that, you will have 7.25 grams, which is given from the problem. Okay, given from the problem, that is 7.25 grams, times write the expression in such a way that you can cancel the gram unit and obtain the mole unit. Because in 1 mole of glucose solution, the molar mass is 180.2. Okay, it has a molar mass of 180.2 grams of glucose. Now we can cancel now here the gram unit. Cancel the gram unit. You will be left out with the mole unit. And then 7.21 times 1 divided by 180.2, that is 4.02 times 10 raised to negative 2 mole of glucose solution. Now, the next thing that you need to do, you already have the mole unit. Okay, you already have the mole unit and you already have the molarity unit. And then to find the volume, I use this triangular expression of M equals N over V. So, takpan nyo lang yan. You will have to find the volume, that's N over M. Divide the mole to the molarity. So, to find the volume, that is, you have to find substitute the number of mole, which is 4.02 from here, 4.02 times 10 raised to negative 2. And then over the molarity, which is 4.21, molarity, instead of writing molarity, because you need to cancel the other units so that you can be left out with the liter unit, you have to expand the molarity unit. Molarity and expanding that unit, that is moles per liter of solution. Therefore, you can now cancel the moles per liter of solution. And also, since you are being asked to find the volume in terms of liters, right? Because it is expressed in, you are being asked to find the volume in terms of milliliters rather. So you have to multiply that into 1,000 milliliter for you to convert that. Okay, so converting that, you will have now finally cancel the liter solution, cancel that as well, cancel. So you will be left out with ml solution. Okay, you cancel the mole, the liter solution, the liter solution. So by doing this, multiplying these two factors here, you will have 9.55 milliliters of solution. Therefore, the volume that she needs in milliliters per solution is 9.55 milliliters for that for the 4.21 moles or molarity of glucose solution that she can do with the addition. Alright, so that is all for this lecture video. Thank you so much.